Hi students, so in this video I'm going to show you how to solve a problem in which a lorry with mass 3500 kilograms is parked at the top of a steep hill with a 1 in 8 gradient. When its handbrake fails, assume that the lorry has a constant frictional resistance to motion of 500 newtons. The lorry rolls down 40 meters down the hill before crashing into a lamp post. Use the principle of conservation of energy to calculate the velocity of the lorry immediately prior to its impact with the lamp post. Now, in order to do this problem, I'm going to use a small diagram. I'm going to draw a small diagram. So this is my steep hill and my lorry is parked at the top. A rough diagram of the lorry. So this is my ground level, and because it is a hill, it is inclined at an angle theta. Now at the bottom of this hill, the lorry rolls down the hill before crashing into a lamp post. There is my lamp post in which my lorry crashes. Now we got to calculate the velocity of the lorry immediately prior to the impact with the lamp post. Now how do you go about solving this problem? Let me complete this hill diagram with completing the three sides of the triangle. Now what information have we been given? The steep the, the lorry has a mass of 3500 kilograms and the gradient of the hill is 1:8. Now whenever you are given the gradient of a hill problem, what gradient means is gradient of a hill is simply slope. Now if you remember, in equation of a line, we learned how to calculate the slope of a line in simultaneous equations. Slope of a line is rise over run. Now this is also equal to tan of theta. So a bit of SOHCAHTOA here. SOHCAHTOA. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So now my tan is opposite over adjacent, opposite over adjacent. And what other information do we have? The lorry rolls down 40 meters. So that distance is 40 meters. Now we got to find this angle theta, and the information that we have is this is 40 meters. Before we find this height h here at which the lorry is inclined, we have to find angle theta. Now how are we going to find it? We are given that the gradient is equal to 1/8. So the gradient is the same as slope of a line. So 1/8 is equal to tan of theta. So now what I do is, from this equation, my angle theta will be equal to tan inverse of 1/8. So shift tan inverse 1 divided by 8, close bracket, that is going to be equal to 7.125, and hence when I round it up, it is equal to 7.13 degrees. So my theta here is 7.13 degrees. Now that I have my angle theta and my hypotenuse side is 40 meters, I can find the value of h using my SOHCAHTOA. Now sine is opposite over hypotenuse. Opposite over hypotenuse. Sine of theta, which is this angle theta here, will be equal to opposite over hypotenuse, which will be equal to, my opposite is side h and hypotenuse, as you can see, is 40. Continuing on this side, sine of 7.13 will be equal to h over 40. Now how do you find the value of sine of 7.13 degrees? Make sure that my calculator is in degree mode, followed by sine of 7.13 close bracket 0.124. So I'm going to write it as 0.12 will be equals to h over 40, and hence my h will be equals to 0.12 times 40, because it is divided by here. When it goes on the other side of the equal to sign, it gets multiplied. So this means my height will be equal to 0.12 times 40, 4.8 meters. So my height h will be equal to 4.8 meters. So once we've got the height, now we use the principle of conservation of energy. Now, by the principle of conservation of energy, the total energy in a system is the same at any given point. So if I mark this as, say, point A and point B, the total energy of this truck at point A will be the same as the total energy in the truck at point B. So now how do you calculate the total energy? Total energy in truck at point A will be, so that's T energy, that's the total energy, energy will be the energy because of the gravitational potential energy plus energy because of the kinetic energy plus work done to overcome friction. Now at this point here, the potential energy, if we take a look at our formula sheet, this is given in gravitational potential energy is mgh and kinetic energy is half mv squared, where m is mass, g is gravity, h is height, and v is the velocity or the speed. So potential energy is given as mass times acceleration due to gravity times height plus kinetic energy is half times mass times velocity squared plus the work done due to overcome friction is frictional force times the distance. Now at this point here, my height will be equal to 4.8. The value of g is the acceleration due to gravity, and it is 9.81 meters per second squared. So m is equal to 3500 times 9.81 times height is 4.8 plus half mv squared. So half times 3500 times my velocity at this point here will be 0 because this truck was parked and the handbrake is still on, so it will not be moving anyway, and hence the velocity v equals to 0. V equals to 0 squared plus the frictional force at this point, okay, it's 500 constantly, times my distance s is the distance covered during the travel. At this point it isn't really moving anywhere, so my distance is 0. So this is going to give me, this expression is going to give me the total energy, and I'm going to enter these numbers in my calculator and find a value. That's 3500 times 9.81 times 4.8 plus, so half times 3500, now this is 0 here, so that is going to be 0 plus 500 times 0 is again 0. That's going to give me 164808. So 164808 joules of energy is present. This truck here at a height 4.8 has an energy of 164.808. Now let us consider that, let's not consider, but now what happens is the handbrake of this lorry fails. The lorry rolls down 40 meters because the handbrake has failed. And what happens at point B? At point B, the total energy will be the same as point A, and hence at point B T total energy will be again the same, energy due to gravitational potential energy plus energy due to kinetic energy plus work done due to friction. Now my gravitational potential energy will be mass times gravity times height h, plus again this will be half mass times v squared plus work done due to friction is force times the distance. At point B, mass is going to be the same, 3500 times gravity is 9.81 times, at point B the height here is 0 because it is at ground level. And that's going to be 0 plus half of mv squared. I'm going to write half as 0.5 times mass is 3500 times velocity is what we got to find, and we don't know because when it reaches this point here, as it rolls down, it will have certain velocity. That's what we got to find, plus the force due to friction, which is 500 Newton. Times the distance traveled. So distance traveled from the truck from the point A to point B. Turn this off. Point A to point B, it has traveled 40 meters. So now this I'm going to equate to the total energy, which is 164 808. Now I'm going to solve this equation. 3500 times 9.81 times 0 will give me a 0, plus 0.5 times 3500. So 0.5 times 3500 is 1750, plus 5 fours are 20 and 3 zeros. That's 20,000. This is going to be equal to 164808. That's 1750 v squared, because this v is multiplied. So now my v is the subject of this equation, and we got to find the value of v. So I am going to get all the numbers on one side and keep the unknowns on the other. So 17550 v squared will be 164808 minus 20,000. 0, 0. So 164808 minus 20,000 will be equals to 144808. That is going to be equal to 1750 v squared. Hence my v squared will be equal to 144808 divided by 1750, because when you move a number which is multiplied by a number, when it goes on the other side, it goes as divide, and hence my v squared will be equal to, I already got the number here already, so that divided by 1750, 82.74, and hence v will be under root of 82.74, which in turn will be equal to, so square root of answer 9.09 or 9.1 meters per second. So in this problem we were asked to find the velocity of the lorry immediately prior to its impact with the lamp post, and at this point here we just calculated the velocity as 9.1 meters per second, which in fact is the velocity of the truck when it impacts the lamp post. Hence this is my answer. Velocity at time of impact. That's it. It's a good practice to highlight your answer so that the examiner knows that this is your final answer. Now what I want you to do is stop this video and try to solve this problem without looking at the video by making a note of the problem. Good luck.